Okay, in this video I'm going to do a basic introduction to a topic related to graph work, and this topic is known as regions of space. Basically what's going to be asked for in an exam question is that you'll be asked somehow to draw 2 or 3 or possibly 4 straight lines. Straight line graphs, using the straight line graph techniques that we've talked about in previous videos. And when you've drawn those 3 or 4 straight line graphs, what you'll be asked to do is to make use of them to then shade in a region of the graph paper, a region of space if you like, that obeys certain conditions. So for example, if I just give you a very crude little sketch, here's the y and the x axis, you might be asked to draw a certain straight line that looks like that. You might be asked to draw another straight line that looks something like that. You might be asked to draw another straight line that looks something like that. So on the axis I've then constructed 3 straight lines. And you will be asked to shade in a region of space on your graph paper that obeys certain conditions to do with those straight line graphs. So for example, a very easy one would be, I might be asked to shade in all the places, all the points which are, if you like, to the left of that straight line. You might be asked to shade in all the places which are above this straight line. Notice I'm putting little arrows on to indicate these directions. And you may also, for this diagonal straight line, be asked to shade in all the regions which are below, in that sense, this straight line. And if you think about it, if it must be, all the places must be below that line, above that line, and to the left of that vertical line, then the region that would be expected to be shaded in, which obeys all those conditions, would be, in this very easy situation, this triangle at the centre of those 3 straight lines. And that is known as a region of space, and it obeys the given conditions associated with the 3 straight line graphs that I plotted. And that is the basic idea behind these straight line regions of space graphs. So in this video, it's just an introduction to regions of space. So I'm not going to do really hard ones. I've explained the basic principle. Let's now do 1 or 2 very simple examples to show how it works. So if I get rid of that, make some space. Question 1 is going to be, I need to shade the region that satisfies these inequalities. This is how the question is phrased in an exam. So shade the region which satisfies these inequalities, and you'll be given some inequalities to set up. So for example, here's the first inequality, x bigger than 2. There will be a second inequality, perhaps y is less than 3. And in some questions you may have 3 or 4 or even 5 inequalities for you to obey and set up and shade as a region of space. For this first example, I'll keep it easy. I'll just do 2 inequalities. Right, to do this region of space, what you need to do is to set up a y and x axis. And I'm going to set up something looking like this. Now, in some questions, the axes that you set up needs to be drawn accurately with proper scales. Other times you can just do a sketch. So it really depends upon the question. For this one, I'm going to do an accurate picture, relatively speaking. I'm not using a ruler, but basically it's going to be a relatively accurate picture. So read the question carefully. Is it accurate or is it a sketch? Sometimes you'll find the axes are set up for you. So if the axis is set up, then obviously it's an accurate diagram on the axis that they are giving you. Okay, so I'm going to mark on the x-axis 0, something like this, 1, 2, like so, and then on the y's, 1, 2, 3. You don't necessarily have to have the same scale on the x and the y. Sometimes it is, sometimes it's not. Okay, what I'm going to do to show all of the graph that obeys those 2 conditions at the same time, it's got to obey both of them, not just one of them, both of them. This is what we do. I would recommend we draw straight line graphs which represent boundaries of regions. So for example, in this first one, we will actually plot a straight line, not x greater than 3, because that's not a straight line graph, but x equals 3. You can see the x and, oh sorry, it's x greater than 2. I should be drawing a straight line x equals 2, not 3. So x equals 2 is the boundary. Now if you think about your straight line graph work, x equals 2 is very simple to draw. It's simply going to the x-axis and you draw a vertical line at 2 on the x-axis. Now, the line that I draw can either be solid or it can be dotted. If x values are greater than 2, it means that they cannot actually equal 2. So if it cannot actually equal 2, it means you must draw your line dotted. So for the moment, just bear with me. I'm going to draw a dotted line at 2 on the x-axis vertically, and I'm going to label it. That is the boundary line x equals 2. Everywhere on that dotted line have x coordinates which are equal to 2. Now I need to show all the places where the x values of any point that I need to talk about, I need to show all the places where x values are bigger than 2. Well, that basically means anything that side of the line where the x numbers get bigger than 2 can be shaded in. Not just on the x-axis itself, but anywhere in this region at all. If you looked at the coordinates of the point, then their x coordinates would be bigger than 2. If it was on the line itself, you might have a coordinate, say there, which would be 3, 0. If it was up here, it would be 3, 3. But it doesn't matter where it is, as long as the x coordinate is bigger than 3. So it's anywhere that side. So I'm going to put little arrows pointing to the right, like so. And I would put them definitely either end of the line, and one in the middle, perhaps like I've done, 2 towards the middle. So anything to the right of the line is acceptable to obey that inequality. And remember, it's dotted because we're not allowed to use the line itself. X cannot equal 2. If x was equal to 2, in other words, don't copy, just watch. If I put that equality symbol in there, that means it would be greater than or equal to it. That means x equals 2, the boundary line itself would be okay, and I would draw that line in a solid line, not dotted. But that equality symbol wasn't there, so it's just x greater than 2, represented by that line there with arrows. In the same sort of way, the second of the boundary inequalities needs to come from y less than 3. So I draw the boundary line itself, y equals 3. That means you go to the y-axis at 3 and you draw a horizontal line from our straight line graph work. There is no equality symbol there, so points on the line itself, y equals 3, are not allowed. So I need to do a dotted line at y equals 3 and label it. Now y needs to be less than 3, so I need to show all the places in the picture with y values less than 3. So I will draw arrows going down like so across the length of that line. Any point underneath that will have y values which are less than 3. So, to shade the region which obeys both of them, we now decide where do I shade if it's got to be below that line and at the same time to the right of that line. Well, I think you can see that it must be in this region here. That region there lies underneath that horizontal dotted line at 3 and to the right of that dotted line. So in this picture, that is the region of the graph that I need to shade. And that is about as easy as these questions get, where you get a very simple vertical and horizontal line to plot and then shade the region which obeys both. So there's the first one. Okay, so we're going to make things slightly harder, but not too difficult in this first video. So if I make some space and put down number 2, let's have a look at a more difficult example. This one here, I'm going to say that minus 4 is less than x, which in turn is less than 3. That's one description of an inequality. And this one is followed by a second inequality which says y is less than or equal to 5. And for this one I'm also going to do an accurate picture. So not a sketch, an accurate picture. So this set of axes may well be given to you by the examiner, and I'm going to set up an axis something like so. And the x numbers, I'm going to go 0, 1, 2 and 3, and down -1, -2, -3, -4. And the y values, I'll go up to 5. I don't need any negative y's to shade this region. Now I've got two inequalities going on here. The second of the two inequalities is very similar to the first example I did, so I'll do that one first. That is y less than or equal to 5. So that means I'm going to draw a boundary y equals 5 to begin with. And because it can be less than or equal to it, I draw the boundary solid. So I go to 5 on the y-axis, and I need to draw a solid line horizontally at y equals 5. Y must be, all the y values, all the points must have y values less than 5. So you put an arrow pointing straight down. So there is the inequality for the second of the two conditions. Now the first one there is slightly different to what I did in question 1. This one here is a slightly different inequality, which has got two inequalities in it. And if you notice what I said when I was writing it down, this sort of thing is very similar to what you see when you're doing group data work. When you're doing group data work, if you want to say, let's collect all weights of objects between, say, 30 and 40 kilograms, we quite often write something like this down. 30 is less than W, which is less than or equal to 40. We say that the group interval for these objects weighing between 30 and 40 kilograms is 30 less than W, which in turn is less than or equal to 40. So that is what you may have seen when you're doing group data work with, say, a bar chart or perhaps a histogram sort of type question. And in the same way, if you see -4 to 3, that means that the x coordinates of all points must lie between -4 and 3, just like this is weights between 30 and 40 kilograms. So, what does that actually mean in practice when you draw the thing? Well, notice first of all that there's no equality symbols, so the lines we're going to draw are dotted. And what we do is, for x values from -4 to 3, on the x-axis you go to -4 and you draw a dotted vertical line. And x must be less than 3, so you go to 3 on the x-axis, you draw a vertical line. And what this is saying is you need to show all the points which have x coordinates which lie between -4 and 3. So if you think about it, they must lie within those two boundary lines. So I need to draw boundaries which are in this sense going to the right, and from this line going to the left. Anywhere in this central region obeys that first inequality. Now what I want now is for 1, 2, 3 boundary lines with those conditions all to be obeyed at the same time, and shade the region which does obey all those conditions. And I think you'll see to the right of that, to the left of that, and below this y equals 5 line, we are shading in this central region here. It's not a rectangle because there is no bottom side which cuts it off. This actually goes on down forevermore to negative infinity, as it were. And so there is the region of the graph that obeys those two conditions. Any point within this region will have coordinates which lie between, for x values, -4 to 3, and their y coordinates will also be less than or equal to 5. Okay, so there's two very basic examples of regions of space that is a starting point for this work, and that's the end of this short video.